Sir Isaac Newton was one of the greatest minds of all time. He was an astronomer and a mathematician and a physicist, and he was the first to define the laws of gravity.
Newton didn't just define gravity. He figured out some other laws too. Most famously, he figured out 3 laws of motion. 3 things that are always true about the way things move. A law is something that is always true, no matter the circumstances. For example, it's against the law to steal. It doesn't matter what or where or from who. Stealing is always against the law.
Bandit, where did you get those treats? Naughty kitty!
I know those treats didn't just walk here by themselves. Oh, hey, that's sort of like Newton's first law. Newton's first law is called inertia, and it says that an object at rest stays at rest, and an object that is moving keeps moving unless acted upon by an outside force.
Inertia tells us that things don't just move by themselves. Something needs to push them or pull them to make them move. This push or pull is called a force.
Sometimes a force is something we can see, like someone kicking a soccer ball. And sometimes the things that stop or move an object are invisible, like air, or like gravity.
Or friction. Rub your hands together. Feel how warm they're getting? That's a type of energy called friction.
Without forces like gravity, air, and friction, there can be no motion. Objects don't necessarily want to move, but smaller objects are much easier to move than larger objects. Larger objects just can't really seem to get going. Because more mass means more inertia.
Whoops.
On this track, gravity is the force that pulls the car down the ramp.
Wait, the law of inertia says that something that's moving keeps moving. So wouldn't the car just keep going forever?
It's important to remember that there is often more than one invisible force pushing or pulling at the same time. When the car reaches the end of the track, gravity is no longer the force in charge. Friction takes over, pushing against the wheels and making the car stop. The invisible force that makes the car go down the ramp is gravity. It keeps moving after it reaches the earth because it has inertia. It's moving, so it keeps moving. Then, the invisible force that makes the car stop is friction. Newton's second law is known as the law of mass and acceleration. Mass is a measure of how much matter something has. So mass is a measure of how heavy something is. This school bus is heavier than this little car. They both have wheels and they both roll. But if I stretch them apart, what do you think will happen? The car moves all the way toward the school bus, but the school bus only moves a little bit. That's because the car has less mass, so more acceleration. If you pedal a big, heavy bicycle, it takes much longer to get up to speed. That's because the bike has more mass than a light bicycle. What do you think would happen if we put the school bus against this heavy monster truck? Yep, the truck pulls the bus.
Which do you think will hit the ground first? The big squash or the little lime? Let's give it a chance. Let's see what happens. Ready? Here it goes.
Look, they land together. Things that are bigger take longer to get up to speed. That's why the squash and the lime land at exactly the same time. Wait, did you see that squash do a cartwheel? Last but not least, we have Newton's third law of motion. For every action, there is an equal and opposite reaction because forces come in pairs. This law explains what things do when they run into other things. You know that if you run into something, you don't just keep going. You bounce back a little. Like if you run into somebody on the playground, you actually bounce back. And if there's somebody bigger, like the squash is bigger than the lime, you bounce back a lot, but they only bounce back a little. But if two things with the same mass, the same amount of matter, run into each other, they both bounce back. Newton discovered that forces come in pairs. Every time there's a push or a pull, there's an equal and opposite push or pull. One way to show this is with what's called a Newton's cradle. When you roll a lime into other limes, only the lime at the bottom moves. Why do you think that's true?